Hello! Today we're going to go over naming simple alkanes. Though there are many compounds with common names, it's necessary to understand how we use the IUPAC naming system to name organic chemical compounds. That's something that you will need moving forward in your STEM careers for sure. The best place to start building this knowledge, though, is with the naming of alkanes, which are hydrocarbons with no double or triple bonds, but they still may be in a ring, so definitely do keep that in mind. For the purposes of this lesson, I will assume that you're already aware of common low number prefixes. What I mean by that is that you understand that if there are two of something, we would prefix that as di, three of something, prefix of tri, and four of something would be prefix of tetra. Like I said, we're not going to be going super in-depth here today, so this will be the only prefix knowledge that you'll need. Beyond that, you're going to need to know common saturated hydrocarbon nomenclature through butane, which is a 4-carbon hydrocarbon. So what we're talking about here is if you have a molecule with one carbon atom that is saturated with 4 hydrogens, we're looking at a methane. If we have 2 carbons saturated again with hydrogen, we're looking at ethane. If we have 3 carbons, we're looking at propane. With 4 carbons, we are looking at butane. These will be necessary for naming these molecules that we're going to be going over today. So definitely do have that knowledge in your brain already, please. Oh, and then also line angle structures. So if you don't know what this means, definitely do go over line angle structures once more. Essentially what you're looking at here, we have 1, 2, 3 carbons, and we are assuming that it is completely saturated, so it's going to have 2 hydrogens here and 3 on each end, making this a propane molecule. Here we have just a different line angle structure with 1, 2, 3, 4 carbons. Again, assuming that it is saturated, we're going to have 2 hydrogens on each center carbon and 3 on each end carbon. So there again, we have the C4H10 set up, so we were looking at butane there. So long as you have that understanding, I think you should be okay to give this at least a starting try. So we're going to go through this step by step. If you follow along in these steps, it's going to make things extremely easy for you. There's not a whole lot of opportunities to make mistakes as long as you follow along here. So the first thing that we need to do is find the longest main chain with the maximum number of substituents, and this will give us the overall molecule name. So the very ending of the molecule will end with methane, ethane, propane, or butane, so we need to figure out which of those that we are dealing with. So this very first one here, it's a little tricky, simply because there's 4 carbons present here, but we need to find a longest continuous chain. So if we look at it, it doesn't matter which way we go on this because it is completely symmetrical, but we have 1, 2, 3 carbons in a chain with something else sticking off that chain, if that makes sense. Hopefully it does. Here again, we've got 1, 2, 3, 4, 5, 6 total carbons. But what we were looking at is one long continuous chain, so we have 1, 2, 3, 4. And here again, it's not going to matter because both substituents are the same, and regardless of which way we're numbering, it's not going to matter, and we'll be going over that here in just a moment as well. And then it gets a little bit more hectic. If you can tell, we just added another methyl group onto each end here. But there again, same thing. We've got 1, 2, 3, 4 continuous chain carbons. We can go whichever direction we would like over on this other side. We can go 1, 2, 3, 4, 1, 2, 3, 4. It really does not matter there, at least as far as we're concerned with right now. But just understand that we need the longest continuous unbroken chain of carbons, and that's going to give us the overall molecule name to start with. Moving on. So now, in step 2, we're going to need to number this to give the first substituent the lowest number. So where most of those molecules we were showing you, it's not really going to matter. There are going to be times where you're going to have to number them a certain way to make sure that the nomenclature comes out correctly. And what we mean by this, I have 2 separate molecules here. Truthfully, they are the same thing. If you rotated this around, you would have this exact same thing. But since we're dealing in 2D, let's go ahead and look at this the way it is presented. On this, we're going to number this 1, 2, 3, 4. That's going to give this substituent a number of 3. But if we number it the other way, 1, 2, 3, 4, this substituent is now on carbon 2, and that's what we like to see. And the reason that I have these both here is just so that we understand that on this molecule, we're going to number from right to left, ending at 4 here. on this molecule, we would need the number from left to right, ending with 4 here, just making sure that that substituent is on the second carbon and not on the third. If we numbered it the other way, that's how that would present. So for step 3, this is where the knowledge of hydrocarbon common names comes into play, because for step 3 we are going to rename these substituents as alkyls instead of just with their regular nomenclature. So if we have a CH4 molecule, it's called methane. If we then take a hydrogen off of that and stick it onto a carbon chain, so we lose a hydrogen, but now this carbon is connected to another carbon, this is still the same basic molecule, but to get the name for the substituent of it, you're just going to cross off ANE, replace it with YL, so this one would become methyl, and that's a methyl group. Moving on, we've got ethane, same thing here. We're going to lose a hydrogen because we are going to now connect one of the carbons to another carbon. Same thing, you just cross off the ANE, and we're going to name this ethyl. So this is an ethyl group. Here we have propane following the same lines. We're going to cross out ANE, and this becomes a propyl group. Apologize for my terrible penmanship. And lastly, on butane, same deal. Just crossing out that ANE, and this is going to become a butyl group. Truthfully, because we are just doing this very introductorily, we're not going to have any butyl or propyl groups, more than likely, in our naming here today, but definitely something that you do want to just understand for the future. So moving on to step 4, for multiple substituents. So this is basically the situation. This is a great example of multiple substituents here. Because 1, 2, 3, 4, we have 1, 2, 3, 4 different methyl groups that are going to be coming off of this thing. In that case, what we're going to need to do is add a prefix, and this is where the knowledge of di, tri, and tetra come into play. So for these first two here, 1, 2, 3, 4, we've got our 4-carbon butane molecule. It doesn't matter which way we number it because it's going to be the same either way. So we'll number it 1, 2, 3, and 4. And we notice that there are 1, 2 methyl groups on this. So this is going to be a dimethyl molecule. And that's where the di comes in. We've got 2 di. Here we've got the same thing, 1, 2, 3, 4. And here again, it's really not going to matter too terribly which way we go, except for, because we have 2 on this side and 1 on this side, we would rather have 2 on the earlier number than the single one here. And the reason for that is that when we do name this thing, and we're going to by the end of this, we are going to have to put 2, 2, because we're going to have to account for both of these methyl groups here, if that makes any sense. So we want them to have the lowest numbers possible. If we were to number this the other way, we would be 1, 2, 3, 3, instead of 2, 2, and 3. And that's where the issue lies, okay? And lastly here, 1, 2, 3, 4. 2, 3, and 4. Here it's not going to matter which way we go. We've got the exact same thing on both sides, but, oh, and by the way, this is going to be a trimethyl butane molecule. Oh, and 1, 2, 3, 4. We've got 1, 2, 3, 4 total methyl groups coming off of this thing, so this is going to be our tetramethyl. So now we're combining both steps 3 and steps 4, because you need to understand that methane becomes methyl, ethane becomes ethyl, and also the prefix for it, if there's 2, 3, or 4, we're at di, tri, and tetramethyl. So definitely combining some things there. But I'm sure you guys can keep up. Alright, and then moving on to step 5, and truthfully today we are going to skip over step 6 because it regards complex substituents, which we are not going to go over today. This is just an introductory lesson. But regardless, here we've got 1, 2, 3, 4, 5, and I know what you're thinking. We didn't talk about 4-carbon molecules, or I'm sorry, 5-carbon molecules, but this is going to be a pentane, and the reason I use this was simply for step 5, showing you that the substituents must be ordered alphabetically by name. And what by name we're talking methyl, ethyl, propyl, and butyl. And we want those to be in alphabetical order. So generally, if you have all 4, butyl would be the first one that you'd want to put because it begins with a B. Ethyl would be the next because it begins with an E, and so on. So hopefully that makes sense. As far as the naming for this, we are going to go over that. We're just going to understand that 1, 2, 3, 4, 5. And we've got 1, 2, 3, 4, 5 carbons, which makes this a pentane molecule. And you don't necessarily need to know that, just understand that that's what this is so that we can move on with the naming of this thing and just understand that the substituents need to be ordered alphabetically. Now the reason that we went from left to right on this molecule instead of right to left is simply because the very first substituent, if we number it this way, is 1, 2, 3. And we certainly don't want that because we can go from here just to number 2 and have 2 substituents right away. And not only that, we'd be at 1, 2, 3 and 4, 4. So we'd be at 3, 4, 4 instead of 2, 2, 3. We want the 2, 2, 3 because that's the lower of the numbers. Hopefully that makes sense for you. So on this, as far as the actual naming of this molecule is going to go, we understand that we have on the second carbon a dimethyl 2,2-dimethyl molecule. And then on carbon 3, we also have this, which is a 2-carbon. We're not going to count this carbon because it's part of the main chain. So we have a 2-carbon substituent, which makes this an ethyl group. Now here's where it gets kind of tricky. We understand that we have a 2,2-dimethyl and a 3-ethyl pentane. That's going to be the name of this molecule, but how are we going to put that together? Do we do numbers first, or do we do letters first? Step 5 tells us we're going to do it alphabetically, so the first thing that we need to write is our 3-ethyl, because E comes before M. And next, we need to also remember to put a dash in between separate groups, just as we put a dash in between numbers and groups, so that we understand that these are different things and we don't mix things up. And so lastly, we do need to get these in here as well, but because they're methyl, regardless of the fact that they're dimethyl, the di does not count for the alphabetical order, just the methyl part. So we are going to have 2, 2, because we need to account for both of those on the second carbon, dash dimethyl. And once you get to this point, this is where adding this part to the very end, and this is why I wasn't too worried about using this, you're just going to toss it onto the very end. So for this molecule, which you probably had no idea what the heck the name of this thing was before you sat down today, 3-ethyl 2,2-dimethyl pentane. And I hope you will take some time, do a couple of homework problems. Definitely try this out, because the best way to learn this stuff is to continuously do it over and over and over. You've been told that. I'm going to tell you again, and I'm going to tell you it's the truth. So definitely do try this out. If you have any questions, feel free to let me know. And if you'd like me to go over any more examples, I'm always here.